I'm really, really happy to be here. This is the culmination of a lot of years of work, just being here. This is a goal of mine, actually, to speak at a conference like this. So I'm happy to see everybody here, and I'm really proud to be here. Today, there have been a lot of talks at the conference so far about simplicity and orthogonality of design. And if any of we're going to walk away from that really fast because there's really not much about Python aside from the language design that's simple or orthogonal, at least not the way that people have chosen to use it. But this talk's going to be about extending Clojure with Python. So, who am I? My name's Chris Nuernberger, and I come from Boulder, Colorado, where it's beautiful and sunny, or it's beautiful and snowy, either way. We'd love to see you guys there sometime. Spent the majority of my career doing kind of computer graphics and GIS and kind of problems that are performance intensive and require a lot of C++ to do. My interests are high performance Clojure. How do we take a sort of numeric problem and make it run really fast in Clojure, and in general, high performance computing. And I really, really like finding the boundaries of a given language and seeing if I can get around them or potentially run right through them. So what is this talk about? This slide, we'll get into this more. Don't worry if you can't read the text on the slide. Fundamentally, what Libpython-clj is, it's a great way to use Python from Clojure. You're going to see a lot of reasons why I think that. And so if you're just, if you're tired of immutable functional design, I give you a great way to do mutable, horrible things from your REPL. So how did this happen? This is a key point. We spent years developing a pathway from C to Clojure and back. I thought that was one thing I enjoyed about C# was they have this amazing system for just calling into libraries that were written in shared libraries, and it works really well, and it was part of the language design. And so I spent a while researching how you do similar things in Java, figured it out, and built a couple tools around it. And then, I guess earlier this year, we were giving a talk on our ML and numeric stack, and Rich was kind enough to join, and he said, in the context specifically of machine learning, not in the context of the broader Clojure world, in machine learning, he said what Clojure, in my opinion, is missing most is the C linkage. The ability to automatically tap into libraries written in Python via C linkage. And then a while later, a friend of mine, Alan Marazzi, wanted to try to use Spacey CPP, and that's a text processing library. Well, text processing. It's a natural language processing library in Python. And so we looked at Spacey CPP. And what I noticed about Spacey is they just called out to the C Libpython calls that are defined in python.h when you install Python on your system. And this is a slide from that talk on ML that I gave, and the last bullet point is really the only one that matters in this talk. It defines the criteria that's necessary for us to play nice with the C library based on the tools that we have now available to us. And it turns out, upon further study, Python is a C library, and it fulfills all of these criteria. So I thought, well, shit, we can do that. We got to it. We did the things required to do some stuff. This screenshot here is from the very first time I actually got a function to work, and the REPL still existed after the function call. Because there were many, many times the REPL did not exist after that function call. And it really, really wasn't easy. I'm used to this. I spent years doing this in NVIDIA, but I spent a lot of time grepping C code and finding hidden things in the shared library. Not all the Python function calls you need to do this style of integration are documented. So I had to just use utilities to scan the library and find all the exported symbols and see if I could get to them. The measuring object sizes, if you get the object sizes wrong that you're communicating with, obviously your program crashes. The beautiful thing about that is it doesn't always crash right away. So it's not always clear like what you messed up. And so throughout all this, my vision was like, could we use Python from Clojure in a very comfortable way? So, you know, Python's mutable, but the Java equivalent of a Python dict is something that derives from java.util.map. It's basically, Python has these various different atoms. They got lists, they have maps, they have strings, they got numbers, and that's pretty much what they got. And so I was trying to think of a way that you could just, what would be a nice representation of Python in Clojure? Not trying to make Python immutable, and really not trying to make Clojure more mutable than it is. And I worked on that a lot. So this is a cool example, I think, because I'm creating a numpy array from persistent vectors. So you can just type in your data, kind of like you would in a lot of different Clojure systems, and out pops this numpy array. And I show here, at the bottom of this slide, I think is interesting because I show that you can both create a vector out of that numpy array, which slices off the first dimension and gives you the 3 rows, and you can map over it, and it's actually Python objects. So that numpy object you can interact with in Clojure in a very natural way, a way that you would expect in Python. If you iterate over a numpy object, you get these same results. For me, because I really don't know a lot about the Python ecosystem, I venture to say that nobody does anymore. So it's really key that there's explorational pathways through Python. And this is a function, and I could be wrong if someone could tell me. I didn't find this in Python, but it's really useful in Clojure. When you don't know what object you have, and a lot of times in Python, you do just kind of get a magic object back. And so you can just kind of scan it and see what are all the attributes on a Python object. And so when I say attributes on a Python object, how many people in the room know what I'm talking about? How many people in the room know the language model behind Python? So not too many. So we'll briefly go into that. Python is a language composed of a dictionary, essentially, of attributes. And what attributes are on that dictionary defines what it is. So if you have underscore iter, then it's an iterable object. And it's all very loosely typed like this. In that sense, Python has a beautiful language model in that sense, and that is very, very simple at the base level. So Python objects are dictionaries. There is a Python dictionary, which defines a set of attributes that are the get and set object protocol. And that's really how Python works. Every time you hit a.b, you're accessing the b attribute of the a object. So it's very simple. It's very straightforward. We all know that nothing bad ever comes of that. This is an interesting part of Python, and so this is a key aspect to some of the magic that makes Libpython work well. Python's reference counted, and many C programs have died in fiery crashes because they got these reference counts wrong. And so for this, we enlist the garbage collector. And in here, you can see I turn on the debug reference logging, so you can see the object address, and you can see kind of how many reference counts it has in this type. But you can see that I call the linspace method, which is just a numpy call, one of about, 4,000. And I then call GC, and it cleans up the references to the object. So this is a general system we actually built as part of our C library. This is one of the things that we invested time in, was trying to figure out every time you deal with C from the JVM, you're going to have some measure of resource allocation and contention and this sort of thing. And reference counting's one version, or using the JVM's garbage collector and kind of getting a callback when it decides to collect an object is one way to do that. As a side note, there's an interesting other way to do that, which is just scopes. So if you use Python from Rust, you end up getting a scope object. We can, in fact, I don't currently put this in the library, but we can, in fact, support both. If you support both scopes and GC-based resource allocation, you end up with a release no later than semantics. The GC is free to clean it up sooner than the scope ends, but the scope will clean it up at that point, regardless of its accessibility to the rest of your program. Python has, the GIL, the global mutex, and man, I don't know how many thousands and thousands and thousands of words have been written about the GIL. It is just like a fundamental aspect of Python, and people always want to work around it, and I think it's the primary reason that Python's threading model is multi-process. So when you want to start new threads in Python, it usually pops off a new process, and that's to get around the GIL because each process has a global interpreter lock. You probably don't need to worry about this slide. We just take care of the GIL with some thread local variables and various things like this to make sure that two threads can't be in it at once, and we always capture it, but we don't capture it more often than we have to, and this sort of thing, but we do it. This is the beauty of Clojure. Right here is one of the beauties, is that this is inside of a macro. This is a function called from the macro that releases the GIL, but I can extend the language of Clojure very easily to do a with open type operation, but one that is very specific to Python and one that has some extra details. I threw this in here. We support with. So speaking of with open, an interesting difference between Python and Java. When you say with open on something, Java basically checks if it's closable or auto-closable. And then it'll call .close on it when that context exits. In Python, it basically calls both an enter method and it calls the exit method, kind of like close. But in Python's case, that exit method has a chance to do something with the in-flight exception. So that's really useful. That takes a second to figure out, but that's really useful because Python, oftentimes you're dealing with native libraries and the information potential in that, if that exception holds on to an object from the native library for some reason or whatever, and it happens to escape your with context, there's a very good chance that just printing the exception to the REPL crashes everything. It's definitely non-zero, and so Python's with is just interesting. It's a different animal a little bit than Clojure's with, and I want to call out Steve Chan. He wrote an issue on our project, and he basically he figured out how to get basically auto differentiation, which we don't have in Java, period, whether it's Clojure or anything else. And he figured out how to get it all working, and we basically worked through the issues of an initial with implementation because you need it for MXNet's auto diff pathway. Zero copy. So this is a big deal to me because, again, this is a side effect of those years spent trying to figure out how the best way to work with C libraries are. In this slide, and I'm going to slow down here and take a minute. In this slide, we create an array, a NumPy array, and we make it accessible to Clojure without copying the data. And you see, I guess, 2/3 through this slide. I set a value in Java on that data, and then I check the array, and the value is different in Python. This is interesting, and the way this works, and I really wish more things worked this way, it's very simple. Of course, in Clojure, there's a protocol that's behind it all. And that protocol has only 4 members that have to be there in order to transfer kind of n-dimensional objects between languages. There's kind of a standard set of things. There's 4 properties. You need the pointer of the data type, the shape, and the stride. And that's it. And that's actually true for quite a few n-dimensional libraries. And it took, a little bit of digging, but somebody happened to implement that protocol for Neanderthal. So I don't know, I thought the talk by Dragan yesterday was really interesting. And here we means that if you have a system that's producing native data, there's a pretty clear pathway to making that data zero copy into NumPy, and then you can use all of NumPy on it, which is amazing in terms of its depth. And so I just didn't say anything else on this slide. Let's take another minute and check it out. But basically, I take a Neanderthal matrix and I just create a NumPy object from it, and I edit it in Clojure, and then you can see both the Neanderthal matrix and the NumPy object have changed. So the vision behind that really is that ideally we can intermix Python execution and Clojure execution in dense ways. So when you don't have zero copy and you're trying to deal with the types of things you run into in data-intensive applications, be it image processing or be it a lot of just basic machine learning, then you can't really use NumPy and then Clojure and then NumPy. You're basically going to get it in NumPy and use it all there, or get it in Clojure and use it all there because your transfer costs are so high. But because we've invested time in understanding the data formats that are sitting underneath these n-dimensional libraries, my hope is that we can write tightly interleaved systems where Clojure becomes essentially, Python really becomes embedded in the language, and we're not paying a lot of transfer costs for flipping between the two different systems. And so, moving on, this is kind of the key point of the slide. When we talk about why we use Clojure, when we enjoy using Clojure, for me, it's a few things. I like the heritage, I have to say, and this isn't a technical reason, but I like the heritage. I've used Common Lisp, I've used all sorts of old languages, and I just like the history behind it and the thought that's gone behind it. So I got into lambda calculus, which looks a lot like Lisp and such. But also, no joke, the REPL. The REPL makes it really nice to use our language. And I'm not really in a position to say whether our REPL is the best in the world, because I don't think I've used every REPL. And before I was going to say something like that, I'd want to use a REPL on a symbolics machine. But I do think our REPL is a lot better than Python. I get really frustrated often in the Python REPL, trying to figure out how to do things and trying to redo them. And at least in Clojure, we have both great language design that fits REPL-oriented programming well, and we have CIDR. Thankfully, we have the whole orchard that, that allows us to kind of use the REPL in great ways. And this is something that Python doesn't have CIDR. So there's a potential that using the REPL through Clojure is a nicer way to develop a lot of Python stuff than using the Python REPL in the first place. And that's kind of one of the things I'd like to kind of explore is, can we make a better REPL experience for Python people? So that part of this whole initiative, I did say this is a random walk through Libpython, so my thoughts are not in linear order, especially not at 10 in the morning. Part of using Python, we want to make a really nice place for the really good Python programmers, because there are so many sophisticated tools in Python, and there's so many really smart people who use Python that in Clojure, if we can make a really nice place for the Python people and pull over just a small percentage of those individuals, man, we get a lot. We will get a lot in our community. So a lot of this, one thought was, I like to do things that aren't easy to do in Clojure. And so some of the numerics libraries I like to use and whatnot, I had to do a lot of work to use in Clojure. I had to do an equivalent amount of work. I had to go through their C code and figure out how they worked and all this other stuff, where they always had really nice Python bindings. And so from my perspective, it's just, can I use the thing I want to use, regardless of the language it's in? But from our perspective as a community, I think it's key that we reach out to some of these other communities. And so I also, at this point, want to give a shout out to Daniel Slutsky, who got Clojure, the community that kind of we were working in and talking about all this stuff in for a while before this happened. He did a lot of work getting that community up and running, and he's an R programmer, and there have been no shortage of really good Clojure engineers that came from R. Like, make no mistake. Other languages have a lot to offer Clojure, and the really good people in other languages have a lot to offer Clojure. And so that's kind of one of the things, and what we have to offer them is a lot of times a way cleaner language model and a great place to live and work. And that's the REPL fundamentally for me a lot of times. I think maybe some of you have seen these images, maybe not, but pretty quickly after we wrote the library, the company that my partner Harold and I work for were engaged to work with a large Python code base doing weather forecasting. And this code base had several different incantations that were all subtly different, and it was dense numeric NumPy written by people who worked at NOAA. So to say that, you know, it's something that you can just read and figure out where the bugs are, even as a professional audit, it's just not realistic. It was really hard to understand this code base. But with Libpython from the Clojure REPL, I could basically import it module by module and mess with each module and kind of take it apart and see how it worked and see how the performance was and all this other things. So pretty quickly, we were able to use Libpython to test and explore this large code base. And as hard as it might be to understand random Python code, understanding random NumPy code is a level beyond that. So it was really helpful, and it helped my understanding of Python a lot to actually dig through this code base and see how someone who knew what they were doing used all these tools kind of in anger, so to speak. And then, of course, we replaced it with Clojure. So we got a chance to try out the full numeric stack and use it for weather forecasting. And these two are pictures of temperatures across the US in the morning and temperatures across the US at noon. And you can see how the one on the right is slightly redder and it moves up. And anyway, I think they're beautiful pictures, and there's no shortage of those that come out of the weather forecasting system, actually. That's a really common thing. So some good things have pretty much already come from this. And these good things are Alan Marazzi, who again instigated kind of the whole thing by asking if you could use Spacey somehow. He wrote pandas bindings, and pandas is an amazing library. There is no equivalent for pandas in Clojure. And so some of you may know or may not know, I've written something that works for a small subset of pandas. It is a data frame library, and it works for big data as long as it's numeric, but pandas is just written, there's just nothing like it. Maybe if you're from R, you know something like it, but pandas is really impressive for tabular data. So at the edge of machine learning, I have a system where if I give it a table, I can predict one column from all the other columns, right? That's the ideal of machine learning in a lot of ways. It's just that. Can I fill in missing values in a column of a table? But at the edge of this, you're doing a lot of things like finding strings and replacing this and finding not numbers and trying to clean the data before you ever get to the chance to even use a model on it or do various statistical operations on it to normalize it. Pandas does all these things incredibly well. So I was really happy to see Alan do this, and he really helped me develop Libpython as he was working on this library. And then kind of the bigger deal is that Libpython-clj got funding from Clojurists Together. So in that case, a gentleman named David Levy is going to work with Daniel Slutsky, who I was talking about earlier, and they're working to make a system that will enable us to very quickly pull new APIs into Clojure from Python. So an example would be Keras, where if you wanted to write a Clojure library, even using Libpython, that hit Keras, you're probably talking like maybe 1,000 different vars that you'd have to define one way or another, 1,000 different functions that you need a doc string for, and they all have different calling conventions, and they do this and they do that. They're going to work to automate that as much as we can. And that'll basically give us a really nice pathway into making any Clojure library, or any Python library really nicely usable from Clojure. And again, it goes to that vision of, can we have Clojure and Python sitting and working intimately with each other in production systems, and in that way bridge one of the larger gaps, which is big data in Java, but all machine learning in Python and R. Where that's concerned, another interesting point is that we're seeing a change in machine learning that I think is important for everybody to recognize, in that we're seeing schools like Galvanize start to really pump out a lot of grads. And these are new people to computer science. They may not have a full computer science background, but they definitely know the math, and they can definitely do machine learning. And so us as Clojure people are going to be interacting with these schools of people that know R or Python, but they don't know much else in terms of lots of different languages. And if your first condition of working with them is, oh, you have to learn my language, they're just not going to respect that. And so we want to be able to use the output of these communities, especially when they're well-trained people from Galvanize. And that's been a central part of one of the things I've realized over time, is that, well, yeah, that's just an important part of doing data science nowadays. So I'm going to start closing her down. I'm going to give you a second to read that slide. It's my favorite one. I think Clojure and Python are actually very complementary languages. I think that they're both typeless. They're both actually really pragmatic at their core. They both started very simple, and I think that using them together, they both feel natural. It is really difficult, in my opinion, it's difficult and frustrating to use Scala libraries from Clojure, because you're dependent on, the version of Scala to the year to the day. They add another dimension to the dependency matrix, as if we don't have enough problems with dependencies in Java. Let's just add a new dimension to the matrix and see if that solves it, which is their compiler version. But of course, because they want to do so many things at compile time, they have an amazing compiler, that dimension's necessary. But the drawback to that is now you've got exponentially more problems in your dependency space than you had to begin with. I'm building that up a little bit, but Python has that problem in a whole new dimension, which is your environment. In Python, you have all these different environments that you can or can't install, and I've had a couple issues on the mailing list where we just couldn't figure out where the guy's shared library was. But Python environments are another form of this kind of like ball of dependency matrix. But I think it's the price to pay for native dependencies, and I think native dependencies are the price to pay for really cutting edge tech. And so that's just kind of where that stands, and that's just how it probably is always going to work. But I think Clojure and Python make a great team. I think we can accomplish a lot more if we can open our doors a little bit to Python, both Python and R, but using R in its native form, so rserve, where you get all the toys, all the plugins, and the full set of libraries and everything. Yeah, so that's my talk. I hope it will encourage you to try Libpython. I hope if you have some friends who know Python who want to learn Clojure, one big selling point now is that they can learn Clojure and they don't have to give up their tooling. So SciPy probably has, you could spend years just learning SciPy. You can do amazing things just with SciPy. Not deep learning, not anything else, just SciPy alone. It's got a lot of functionality. And now, if I'm coming from Python, again, if the first thing I've spent 3 or 4 years learning to do machine learning in Python, and now you're like, oh, you get to relearn machine learning using libraries that maybe don't have the tools you expect, again, I'm not going to respect that. I'm not going to enjoy that work. So in this way, we can build a very solid kind of platform that both communities can sit in and interact with really well. So thank you, guys.